All right, welcome to part 3 here in 1.2. We're going to be talking about approximating relative extrema, so extreme points on our graph, minimum points, lowest points, and maximum points, highest points. We're not going to be talking about only the highest overall point or the lowest overall point. We're also going to be talking about points that are called relative minimums and relative maximums, or generically relative extrema. That's both minimums and maximums. So if you look here at this picture, we have this, looks like a third degree polynomial. A cubic is another word for that. You can see we do have these points like D and B. They're not the minimum point, right? B is not the lowest point on this graph. This graph actually moves down far below this point B. But what we can call B is we can call it a relative minimum. So this is a term that we'll be using, a relative minimum. It's sort of the lowest point in its region, right? It's kind of the bottom of a curve at a particular point, right? Notice this graph's decreasing, decreasing, decreasing. It hits this relative minimum and it turns around and starts increasing. So these are the points where it changes from decreasing to increasing. We call these points minimums or maximums, or relative minimums and relative maximums if they're not the lowest or the highest point on the graph. So B here is a relative minimum, and point D, again, it's not the highest point on the graph, but it is the highest point around it, right? It's where it turns around. The graph is increasing. It hits this sort of peak here, and then it goes down. So we call this a relative maximum. And a lot of polynomial functions and many others are going to have these relative minimums and relative maximums, in addition to possible, global minimums or global maximums, which would be the highest and lowest points overall on the function. Anyway, in calculus, you're going to learn some methods to find these special points, in particular using the derivative function. But for right now, what we're going to be doing is we're going to be using a calculator or Desmos to approximate these values. And turns out it's actually pretty easy. We can just type it in there, make sure we can see these points, and then more or less Desmos will find, or the calculator will find those answers. All right. Okay, here's a question here. Identify which points are relative minimums and which points are relative maximums. And if we have any overall minimums or maximums, those would be worth looking at. So here we have a couple points that we would consider to be relative maximums. Again, they're sort of like the tops of these hills, highest point in their neighborhoods. So we have points A and B that are relative maximums. Relative maximums. A and D. And then we have these points down here. We have point B and point E, which are relative minimums. Relative minimum. We have another point that's actually marked on here that's not a minimum or a maximum. This is an x-intercept. Those are important points, and we'll definitely talk about those throughout the class, but it's not a minimum or maximum point. Just thought I should mention that. So anyway, we have two relative maximums, two relative minimums in this polynomial function that we're looking at here. Again, I kind of know these are polynomial functions because that's just kind of the general shape that these types of graphs create. There's no scaling on it to indicate it or anything. Let's go ahead and clear this and move forward, look at another one. Here's another function. We have a few important points here, a few relative extrema. We have a couple relative maximums right here. And then actually point F is not only a relative maximum, it is the maximum. It is the highest this graph goes. Another word we sometimes use or sometimes we'll see for this is we'll call it a global maximum. It's the highest point on the graph overall. There's no higher point on this graph. And you can see that it continues going down in both directions. So we know it'll never exceed that particular point. But these 2 points down here, they're not the highest point overall, but they are relative maximums. And then we also have a couple relative minimums. So we have this point B and D, which are both relative minimums. It's going to be important for us to find those particular points in the future. They often hold particular importance in real world problems that these graphs may represent. And again, we have a couple other special points here. Again, these are x-intercepts, though they aren't minimums or maximums. Let's go ahead and move forward. All right, so here is an example of using Desmos to approximate these values. So I went ahead and plugged this into the Desmos graphing calculator, and we got this point right here. A great thing about Desmos is when you do actually type it in, it'll automatically mark these points. These are known kind of important points, and all you have to do is just click on it. So there'll be kind of a gray dot there. And if you click on it, it'll tell you what the point is. So our relative minimum value, or actually in this case, it's not even just a relative minimum, it is the minimum or a global minimum, is negative 2.625. Now, for the most part, when we are asked these questions, we're looking for the output, right? We want to know the output. What is the lowest output that this function has? But it's possible we may also want the whole coordinate point. We may want to actually know what the x value is at that place. So, we could be asked for just the output or both as a coordinate point. So it's worth knowing both. Also, when you're doing the Delta Math assignment for this week, it actually asks you to round this to the nearest hundredth, so 2 decimal places. So be careful with that. So in this case, it would be negative 2.63, right? There is a very, very small chance because Desmos is already rounding this to 3 decimal places. It's possible to run into a situation where this third digit was rounded up to a 5, and therefore when you round it up again, you're actually double rounding and you'll get the wrong answer. So you have to be careful. If it happens, it happens. Just move on and do another one. Anyway, we'll take a look at some graphs on Desmos here in just a minute. So here we go. Let's go ahead and type these equations into Desmos and try to identify their minimums and maximums. I'm actually just going to do a couple of them, and then I think we'll get the point here. So let's go to Desmos. All right, I'm covering a little too much of my screen here. Okay, so negative x squared plus 6x. So f of x equals negative x squared plus 6x. All right. The thing with these questions is you want to make sure that you can actually see your minimums and maximum values. And notice how when I have the function highlighted, it does give me this sort of gray dot here. And so I can find that maximum value very easily just by clicking on it. And again, depending on the type of answer we're being asked for, whether that's a full coordinate point or just the output, we'd want to give the appropriate answer. So 3,9. Just 9. Okay, let's go ahead and type in the second one here. So 2x cubed, 3x squared minus 12x. Let's just do this. 2x cubed. Already forgot what I was supposed to do. Plus 3x squared minus 12x. Plus 3x squared minus 12x. Make sure that's turned on. With some of these, again, you're just looking for the minimums and maximums, so the graph doesn't need to be beautiful. You don't need to change the graph settings so much. Just zoom out until you can see it. Right? As long as you can see it and click on it, you're going to be good to go. So there we go. We can see those. We have a relative maximum here, and we have a relative minimum here. Again, give the appropriate answer for those. Let's go ahead and go back and do one more of these. Let's go ahead and do this one right here. We'll do this. So parentheses x minus 1. Parentheses x, oh, I meant to delete that. x minus 1, and then square root. So I'm just going to start typing SQRT, and it gives me that symbol, x. Alrighty, again, just zoom in until you can sort of see it. I definitely can see it already, but I want to make sure I don't click on the wrong thing. And then you can just kind of drag the graph around. So here's a minimum value. So we have a minimum right there. And it's kind of worthwhile just to make sure nothing else is happening farther off. So I'm going to zoom out. Yeah, it looks like it just keeps going up forever. So there's no other minimums or maximums anywhere. We just have this one. Oops, with that. We just have this one minimum value right here. And actually, this is a global minimum or an absolute minimum, the lowest point overall. Again, if you're giving this answer as for the Delta Math assignment, be careful, round to 2 decimal places. But because Desmos is already rounding, you could run into some small issues. I'm sorry, that's just the way it is. But do your best with it. If you get it wrong, try another one, shouldn't take too long. All right, and yeah, that's basically it. It's really just making sure you can do it here. I will show you how to use the blue calculators when we get into class. It's just a matter of approximating. Anyway, see you guys in the last part.